Good afternoon, children. In this year's physics, we have 5 chapters in all, under 2 units. The first unit we have electricity, in which we are going to discuss few topics regarding electricity. We have 2 chapters pertaining to electricity, that is electricity and magnetic effects of electric current. And this is added with one more chapter, sources of energy. So we have 3 chapters in the unit energy. Coming to the second unit, under which we will study light, reflection and refraction, and few other phenomena pertaining to reflection, refraction. And we will also study about the construction and working of human eye, its working, and few other aspects pertaining to different concepts of optics. To start with, electricity. We all know that electricity is widely used. We cannot imagine the modern civilization without electricity. Of all the 16 or 17 sources of energy which we know, we have electricity being widely used. What makes electricity a viable source of energy? Electricity is a viable source of energy for 2 reasons. One is transmission, that we can transport electricity from the point where we generate it to different other parts where we use it using cables. In fact, electricity is such a source of energy which is easily transportable, and therefore transmission is one of the important aspects what makes electricity a good source of energy. Secondly, after transmission, we have another advantage with electricity, that is transformation. We all know transformation is change of form of energy from one form to another. We will find that electricity is easily transformed into different other forms. We understand that electricity is easily transformed into mechanical energy in the different types of motors we use. And electricity is transformed into light, where we use different sources of light like lamps, bulbs, etc. So transformation and transmission, these are the 2 important aspects which make electric energy a viable source of energy. That's the reason why we extensively use electricity. The modern civilization is totally dependent upon this gigantic source of energy. That's because of these 2 reasons, transformation and transmission, which are easily made with electric energy. Regarding electricity, you must have studied about electricity in your earlier classes, somewhere around in class 8, where we studied about charges. You must have studied about how objects can be charged by rubbing on different surfaces, by rubbing a glass rod being rubbed by a silk cloth or a woolen cloth. In all these situations, where we studied about charges at rest, where the object gets charged temporarily. But in this year's electricity, we talked about current electricity. What do you mean by current electricity? In current electricity, we discuss about charges which are in motion. So no sooner you switch on any electrical appliance, we find that the appliance starts working because of the flow of electric current to it. Mind the word current. What is current? Current means flow. Any flow is called current. Like water current, wind current, where wind blows. Water current is where water flows. In current electricity, we discussed about charges which are in motion. When we enable charges to move, that forms current electricity. So in this chapter, we shall focus upon learning more and more about current electricity. So electric current is defined as the rate of flow of charge. Rate of flow of charges is what we call as electric current. So defining this, we can write it as so the rate at which charges are flowing, the speed at which charges are flowing is what we term as electric current. So obviously from this we can write electric current I is equal to Q, the quantity of charge flowing, divided with the time taken, t seconds. So I is equal to Q by T, where Q represents the total quantity of charge which is flowing and T is the time of flow of charge. Electric current is measured in units called amperes, named after a French scientist, Henry Ampere. Now the smaller units for ampere is 1 ampere is equal to 1000 milliamps, and 1 milliamp is further divided into 1000 microamps. So 1 ampere is 1000 milliamperes and 1 milliampere is equal to 1000 microamperes. This means 1 ampere will be equal to 10 power 6 microamperes. So smaller currents are measured in milliamperes and further smaller currents are measured in microamperes. But for charges to flow, there should be a continuity for their movement. This continuous closed path which enables charges to move is what we call as an electric circuit. So if charges are to move to contribute for electric current, there should be a continuous path, and this continuous path is what we call as an electric circuit. You must have noticed that in any electric circuit. Let's take the smallest of the electric circuits, like a torch light which has a small bulb, one or two cells and a switch, and all these are connected with small copper wires inside, or at times the metallic body may itself act as the conductor. So for electric current to flow, that is the charges to flow, there should be a continuous and closed path, what we term as electric circuit. This electric circuit is represented diagrammatically, what we call as circuit diagram. So now we will try to understand a circuit diagram. So this is the simplest of the circuit diagrams which we were just talking about, representing a torch light, the circuit of a torch light. So you have battery, you have a small bulb or lamp, and then you have switch, and these lines are nothing but the connecting wires, the copper wires used or the metallic body of the torchlight itself. So if you represent any circuit diagrammatically like this, you call it a circuit diagram. And for this circuit diagram, you have many symbols. So this represents a lamp, this represents a plug key, and this represents cells on battery, and these lines has the connecting copper wires which we use for electric supply. So there are enormous symbols whereby we can use for drawing different electric circuits. For each and every component of which are used in electricity as well as electronics, there are different symbolic representations. A set of symbolic representations is given as well in your textbook. You can refer to it, and I, along with the notes, am also sending those symbols. So go through these symbols, whereby further we will try to draw more and more circuit diagrams. So mind it, for any circuit diagram we use symbolic representations for all the components, and you need to observe the symbolic representations very carefully. Try understand using these symbols, and then you can put them into use when we draw the circuit diagrams.